Hi and welcome back to Free Science Lessons. By the end of this video, you should be able to describe the trend in the reactivity of group 2 elements down the group. You should then be able to explain the trend in terms of ionisation energy. I'm showing you here the first 5 elements in group 2. Elements in group 2 are referred to as the alkaline earth metals, and a key idea you need to remember is that alkaline earth metals are reactive. Now all of the elements in group 2 have 2 electrons in the s subshell of their outer shell, and I'm showing you the shorthand electron configurations here. When group 2 elements react, these 2 outer electrons are lost, and by transferring these 2 electrons to other species, group 2 metals act as reducing agents. I'm showing you that here with magnesium. When magnesium reacts, it loses its outer 2 electrons to form the magnesium ion Mg2+. Because it has lost electrons, the magnesium atom has been oxidized. I'm showing these 2 electrons being transferred onto a different chemical species, which in this case I'm calling X. By accepting the electrons, X is being reduced. So as you can see, in this reaction, the magnesium is acting as a reducing agent. Now the reactivity of the metals increases as we move down group 2, and you need to be able to explain why. I'm showing you here the electron shells of magnesium. As we've seen, when group 2 elements react, they lose their outer 2 electrons, and we can see that here with magnesium. Now to remove an electron from an atom requires energy, and scientists call this the ionisation energy, and we've seen ionisation energy in previous videos. Because we're removing 2 electrons, this involves the first ionisation energy, plus the second ionisation energy. I'm showing you here the electron shells of calcium. Calcium is below magnesium in group 2. Now both the first and second ionisation energies for calcium are less than for magnesium. There are 2 reasons for this. Firstly, calcium has a greater atomic radius than magnesium, so the 2 outer electrons in calcium are further from the nucleus compared to magnesium. Secondly, calcium atoms have one more full inner electron shell than magnesium. As we've seen, full inner electron shells partially screen the outer electrons from the positive charge of the nucleus. So for both of these reasons, the outer electrons in calcium are less strongly attracted to the nucleus than the outer electrons in magnesium. And this means that calcium has a lower first and second ionisation energies compared to magnesium. So because it takes less energy to remove the outer electrons, calcium is more reactive than magnesium. And this trend in ionisation energy explains why the elements get more reactive down group 2. In the next video, we look at the redox reactions of group 2 elements.